Hi guys, my name is Chris and welcome to my first video of my new series Z80 with bread, in which I will be trying to build a breadboard computer centered around this Z80 CPU. So let's get started. So the goal of today's video is to connect an EEPROM and run some code from the EEPROM on the CPU. But before we can run the code, we need to hook up some important pins on the CPU. And to do that, I will be using this datasheet and this page from the datasheet. This page shows the CPU pin configurations, it shows the address bus, data bus, IRQ, halt, and other signals, and I will be mapping those to this pin package configuration. So I will just go through this datasheet and connect the Z80. So we can see here, this is A11 through A15, and this is the address bus, and I will just leave it unconnected for now. The pin 6 is the clock line, and for the clock I don't have a crystal, but I have this PIC16 that has been programmed to output its internal oscillator on, I think, this pin. So I will just plug the PIC to the breadboard. If it wants to go, now we can go through the other pins. D4, D3, D5, D6 is the data bus. I will also leave it unconnected. +5, pin 11, and I will connect +5 to positive rail. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 will go high, and this should be the 5 volts. I will double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Pin 12 through pin 15 is also the data bus, so that is unconnected. Int is the interrupt, maskable interrupt, and it has a line above it, and that means that it is active low. And for now I won't use interrupts, so I will just tie the int high. And int is pin 16, and it is 5th from the bottom. So 1, 2, 3, 4, 5. This should be the int line. Under that is the non-maskable interrupt, and it also has the line. So I will also connect it to 5 volts. Halt is an output, and we can see the outputs by these arrows. If it points to the chip, it is an input, and if it points out, it is an output. So memory request and IO request is an output, so I will leave it unconnected. Read, write, bus acknowledge is also an output, so we can leave it unconnected. Wait is active low, and it is an input, and I need to look what wait does. And wait is an input, active low. Wait indicates to the Z80 CPU that the address memory or I/O device are not ready for data transfer. So I will just connect it high. So I will connect the wait high, because it also has the line above it, and that means it is active low. And it is fourth from the bottom. 1, 2, 3, 4. This should be the, if it wants to go in. And now we can continue. Bus request. I don't remember what it is, so look at the datasheet. We can see the bus request. It is an input active low. The bus request signal has a higher priority than non-maskable interrupt, and it is always recognized at the end of the current machine cycle, and it is used to request the CPU address bus. So I think I will just connect it high because I don't need it. So bus request is above the wait, so it is here. And now we have the reset, and the reset is a special one because if it stays here, yes, it is an input active low and it initializes the CPU, but it should be low only for 4 clock cycles of the CPU to reset it. So I will just hook some passive components like a capacitor, a diode, and a resistor, and I will look at the internet for some reset circuit for the CPU, and I will be back. And I found this simple diagram for the reset, so I will just connect it. So we have a 1 microfarad capacitor that should be connected between the reset, and the reset should be above the bus request. Yes, and I will just connect a capacitor to ground. Where did I put it? Here. And there should be a resistor tied to 5 volts. And also a diode with the black stripe to the 5 volts. So I will just plug it in the same holes as the resistor if it wants to go. I will just snip the legs to make it easier. Now I will get some tweezers. Go in. These cheap breadboards are not very good. It should be in. And now for the diode. The black stripe to the 5 volts. And like here. And now it is connected. So now we just go, we can continue. Above the reset we have M1, which is the machine cycle, and it is an output, so we don't have to worry. Refresh, also an output, and ground, which we will connect to ground. And this is the reset, machine cycle, refresh, and ground. Here and here. So read, write, bus acknowledge, wait, bus request, reset, machine cycle, refresh, and ground. And this is the rest of the address bus. So now I will connect the PIC, the output from the PIC, to the clock source, which is pin 6 on the Z80. And I need to look at how the PIC is configured and which is the output pin for the clock. So give me a few seconds. So after looking at the PIC datasheet, I found that the clock out from the PIC is on the RA4, and that should be right here. So I will just connect it to pin 6, which is 1, 2, 3, 4, 5, 6, and this should be the clock. And also I will just connect the PIC to power, and this should be the plus, so +5, and this should be minus or ground. So now it should work. So now I think I will just connect the EEPROM, and I have the EEPROM here, which is a win bond, and it should be 128 kilobytes. I'm not sure. I would need to look up the datasheet, but I will plug it in the breadboard, I think here, and I will get the datasheet for it and we will hook it up. So I have found the datasheet, but I printed it wrong, but it shouldn't matter. And the EEPROM is 2 megabit, so not 128K. but that doesn't matter. Here we have the pinout. It is really small. So we will go through these pins on the EEPROM and connect them. And I will start with the power pins. So I will connect ground, which is pin 16, which is here, to ground. And I will connect 5 volts, which is right up here, which is here. These wires are really bad. I will throw these out. I have a new one. And this breadboard is oh so very bad. It is in. Now I will go through the signals from the CPU, and I will start with the address bus. So we have the CPU configuration here, and the A0 is above the ground, so it is here. And I will get a jumper wire, and I will connect A0 to A0 is here, and it is the 5th pin, and the wire is not long enough. This should do the trick. A0 and the 5th. 1, 2, see? 1, 2, 3, 4, 5. This should be the A0. And now to connect the A1. A1 should be above, and it is A1, and A1 on the EEPROM is right above A0, so here. Next is the A3, which is above the A1, sorry, and it is right here. Now the A3 above A2 and above A2. Next, the A4, which is right here, and A4 is right above A3. Now for the A5. A6. A7. A9. And the A9 on the EEPROM is on the other side, and it is pin 26. So go on the other side, and it is A9. Oh, A8, not A9. A8 is correctly on the CPU, so A8 on the EEPROM, and it is 27th. Uh, the it is 27th pin on the EEPROM. So 32, 31, 30, 29, 28, 27. This should be the A8. Now for the A9, which is under the A8. Now for the A10, which is here, and the A10 is, this is the A9. Under that is A11, under that is output enable, and under that is A10. And I will just connect I will also connect the output enable, and it should be low because it has the hashtag before the letters, and that signalizes that it is active low. So I will get some jumper wires, and this is the A11, this is the output enable, and it is tied low. I will also connect the chip enable, also low, because it also has the hashtag. And now we can continue. A10. We will now connect the A11, and A11 is on the other side of the CPU. So it is right here, and A11 is here on the EEPROM. We have A11, now A12, and A12 is here, which is above A7. So I will plug it here and connect it here. Now for the A13, which is here on the CPU, and A13 on the EEPROM is on the other side of the chip. So I will connect it to the other side, right above the A8. Now for the A14, which is right here on the CPU, and A14 is above A13. And I will just connect write enable to high because I don't want the CPU to write to the chip. And write enable is right under the VDD. So now we will connect the data bus of the EEPROM to the CPU, and the data bus on the CPU is right here around the 5 volts on this side. So D0 is pin 14, and I will get wire. I don't have many long wires. A14, and it is above the one, which is pin 15. This is the D1 because it is on top it is above the interrupt. So this should be the D0, and D0 on the EEPROM is right here under A0. So should be right here. Now for the D1. D1 is under D0, and D1 is under D0 also on the CPU. We can see it here. Now for the D2. D2 is under 5 volts on the CPU, which is here. Oh, I'm connecting it wrong. This wire is the 5 volts. This is the interrupt. So this is the D0, and it should be here, and this should be here, and D2 should be under 5 volt, which is here, and it should be connected here, right above the ground on the EEPROM. Now for the D3, I don't have long wires, so I think it will be a challenge. And D3 on the CPU is under D4, and D4 is under the clock, so it should be here. This is D4 and this is D3, and this won't reach, so I think I will need to move the chip closer, so give me a second. So I got back and I reconnected the address and the data to where we left off, and we can continue. So now we are going to connect D3, and D3 is at pin 8, and pin 8 is under D4, and D4 is under the clock, so it is right here, and D3 is at the bottom of the chip, so go under the wires and connect it. Now for the D4, and D4 is above the D3, I will also go under the wires, and D4 is above D3 on the EEPROM, so it is right here. This is the, you can see this is the D4. Now D5, and D5 on the CPU is under D3, so it is right here, and also under the wires, and D5 is here above D4. D6 now. I will get a shorter wire. D6 is under D5, and it is here. It is above 5 volts, so here and here. Now we have D6, and the last one is D7, and D7 is right here, just below the chip enable on the EEPROM, and also under the wires, and the 7 is under D2. Now that we have the EEPROM connected, I will connect the unused pins from the EEPROM, like the A15, A16 and A17. I will connect them to ground through a 1K resistor. So now the A15, which is right here, connected to ground. A16 also to ground. And lastly A17, which is right here. For now I won't use the A15, but later I will use the A15 line to switch between RAM and ROM, so we can get some memory separation. And now I will just try to plug it in and see if it does anything. I will rotate it and I will get my LED breadboard, and I will connect the LEDs to some of the pins on the CPU. So I will connect to memory request, IO request, halt, and read write. I think I will try. No, I would need to go under the wires, so I think for now I will just look at the IO request, memory request and halt. So I will plug the ground wire and I will use these. So this should be the halt, this should be the memory request, this should be the IO request. And now I will just try to plug it in and see if anything happens. And moment of truth. And we have some lights. It looks like something is going on. I don't know what. But lights are lighting up. So I will disconnect it. And now we will write some code. So now we can develop some code for the Z80. And some extremely basic code that we can test on the Z80 is the halt, because if the CPU executes the halt opcode, it pulls down the halt line on the CPU and we can look at the halt line. So I will create a label start and I will just put the opcode here, halt. And I have the Z80 extension. It shows me the opcodes and the flags that the opcode modifies. And we can see this is the opcode hex 76. So now I will just assemble the program. I have Z80ADK installed, so it should be easy. I will just Z80 ASM and main.asm. I will look at the command line, and I want to use I think I will just use the basic. So I will use Z80 ASM, and the parameter is main.asm, and it should be assembled main.o. Can I output binary file? Oh, it is right here. So I will put -b and I have the binary. So now I will just program the EEPROM and we'll see if it works. So now the EEPROM should be flashed, and I can plug the EEPROM back in, and we can test by looking at this LED, and if it is off, it should mean that it has successfully read from the EEPROM and the CPU should be halted. So we can test. I will zoom out a little bit, and I will press start, and it doesn't look like anything is working. Oh, I know, I'm stupid. I plugged the EEPROM wrong. It should be here, right next to the CPU, right here. Now we can test that. I'm stupid. Now we can test it. And now look, the LED is off. So we have successfully executed code from the EEPROM. And I'm really happy. So I think that is all for today's video. And in the next video, I will try using a address decoder, and we will be making a address decoder using some CPLDs, and we will be also trying to program this Z80 PIO, and this is the programmable input output. So thank you for watching, and I'll hope you see you next time. So bye.